Good morning, class. Here's exam 3 review. Chapter 3, differentiation rules. Chapter 4, application of differentiations. And this exam covers from section 3.9 to 3.11 and 4.1 to 4.5. Here's the second part, 3.10, 3.11, 3.10, linear approximation and differentials, 3.11, hyperbolic functions. Those are the ones we're going to cover. So first and foremost, linear approximation and differentials. Here's the definition. For a function y equals f of x, we define dx called the differential of x by dx equals delta x. So you have a curve and the run along the x-axis, this distance, if we pick 2 points, this distance is called delta x, which is identical to dx, which is the distance of BP. That's dx. And dy called the differential of y by dy equals f prime of x dx. Now, what is dy? Dy, when you look at this curve, the change along the y-axis for the curve, we call it delta y, which is the distance from B to Q. And if you have a tangent line at this point, this distance of AB is dy, which is equal to f prime of x dx. This is the definition. So we can replace delta y, change in y along the curve, by dy, change in y along the tangent line for a function f, which is a continuous and differentiable function with a small delta x. Now, this, for the sake of illustration, has been blown up, and delta x seems to be huge, but on a normal basis, this distance is small. The smaller the delta x or dx, the closer the value of BQ, which is delta y, to AB, which is dy. Again, delta y is not equal to dy, but if this is small, it can be approximated by that. So we write f prime of x is dy dx. If you treat this as a fraction, cross product gives us dy equals f prime of x dx, which is known as the differential of y. Delta y is f of x plus delta x minus f of x. That's by definition, this is the precise value. Delta y is this distance. So f of x plus delta x minus f of x. This distance of BQ, this distance is delta y. We know f prime is dy dx. If we approximate it by delta y over delta x, therefore, we can say delta y is the product of f prime of x and delta x. Instead of f prime of x and dx, we can use dx or delta x. They're identical. Now, so here's the summary. Delta y is precisely f of x plus delta x minus f of x. If you move the minus f of x to the right, f of x plus delta x is f of x plus delta y. So in other words, this distance is f of x. This distance is delta y. If we add these two distances, we get the distance of CQ, which is f of x plus delta x. That's what it says here. We know f prime is dy dx, therefore dy is f prime of x dx. And we can replace this delta y with dy, and this becomes an approximation. Equality becomes an approximation. The second method to approach that is called linearization. When we say linearization, it refers to finding the tangent line at some point A. So if we find the tangent line at this point, and all you have to remember is really the point slope, y minus y1 equals m times x minus x of 1. Now, I can move the y sub 1 to the right, becomes plus. I can replace the m with f prime of a, as you recall, and x sub 1 with a, y sub 1 with f of a. And now I'm going to change the y to L of x. That's called linearization. Do we have to memorize this formula? Not really. Just remember the point slope from elementary algebra, everybody. Elementary algebra. All right. Y is x times 4 minus x cubed. We want to find dy. And we know dy is f prime of x dx. The moment you hear dy, just differentiate first. Find f prime of x or dy dx, which means we are going to use the product rule first. X gives you 1. One times 4 minus x cubed plus g prime. What is the derivative of the second piece? 3 times 4 minus x squared times the derivative of the inside, which is negative 1. So 3 becomes a coefficient, the same thing to the power of 3 minus 1 or 2. The derivative of the inside by the chain rule is minus 1 times f times this function x. And we are going to simplify this. I hope you recognize that 4 minus x is in common. Exponents 3 versus 2. We're going to go with the smaller of the two. 4 minus x quantity squared. This is in common. So if you take this out, from here, we are left with 4 minus x to the power of 1, or simply 4 minus x. From here, this is gone. We have 3, negative 1, and x. Their product is minus 3x. So the first piece gives us 4 minus x. The second one gives us minus 3x. The combination of these two is negative 4x. Now, we can take the negative 4 out from here. We put the negative 4 in front. And this is f prime of x, or dy dx. So what is dy? The same thing times dx. The same thing times dx. Now, we want to find both of them, dy and delta y, when x is 5, replace the x with 5, and dx or delta x with 0.2. This is basic math. Plug in, evaluate. Obviously, 4 minus 5 is 1. 1 squared makes it 1. So it's minus 4 times 1 times 4 times 0.2. We get negative 16 times 0.2, which is negative 3.2. To find delta y, we are going to use this formula, f of x plus delta x minus f of x, which means f of 5.2 minus f of 5. So we're going to replace the x with 5.2. That gives us an answer. We're going to replace the x with 5. That gives us a different answer. I'm going to assume everybody can calculate that. And we get minus 3.64. It's pretty close to dy. By the way, the smaller this value, in a matter of comparison to the choice of x, the better this approximation. All right, we want to differentiate first. ln of sine theta. As you know, anytime you're dealing with a natural log, you flip over the function. So 1 over sine theta. And then by the chain rule, the derivative of the inside, the derivative of sine, as you know, is cosine, which results in cosine theta over sine theta, which is cotangent theta. In this case, we use the quotient rule. And as you know, quotient rule is shorthand notation, f prime g minus g prime f over g squared. Therefore, the derivative of the top is itself times the bottom one minus e to the power of x Okay, this is supposed to be x. Times 1 plus x. This is supposed to be plus x. And minus g prime. So the derivative of the bottom is just 1 minus 1 times the top e to the power of x. And then g squared, just write the bottom, 1 plus x in a parenthesis and a square. We're done with calculus. So we do our algebraic techniques. The top, if we multiply these two, we get e to the power of x, these two e to the power of x times x, and this is minus e to the power of x. As you can see, these two cancel each other. And the numerator is e to the power of x times x. We put the x in front because that's the proper notation. And the purpose of this question was actually to find the differential of each function. So in order to find dy, all we have to do, just tag along, in this case, d theta, because this y prime, and let me write this. In this case, y prime is dy d theta, because theta is the independent variable. Whereas here is dy dx, because x is the independent variable. So it's the same thing times dx. So I want you to distinguish between the two and remember which variable is your independent variable and act accordingly. All right, we want to use differentials to approximate 51 squared. So when you come across a case like that, you need a couple of things. Number one, you need a function. So you let f of x be something. And to do so, all you have to do, just read the operation that is taking place. 51 squared, you are squaring the number. Therefore, you let f of x be x squared. So the operation should result in the function of interest. The next one is to find the closest number to the given number. In this case, it's 51. So that we can easily square, there is no reason for a calculator. And I hope everybody knows, obviously, that's 50, because 50 squared is 2,500. So you square 5, you get 25. And because there is 1 0, you put 2 zeros. That's how you do that. And so we can go through the process. As we can see, we want to go from 50 to 51. So we're going to go up by 1. So delta x or dx is positive 1 because 51 minus 50 is 1. However, if we were dealing with something like, let's say for the sake of argument, we were interested in 48 squared. In this case, dx would be -2, okay? So the sign makes a huge difference. And so first and foremost, we are going to find the dy because we are going to use this approximation. So what is f prime of x or dy dx? 2x. Okay, we're going to use that. Okay, everybody. To use that, we need the function. We have it. We want dy. So let's find f prime of x, which is 2x. And therefore, dy is simply 2x dx. And now we replace this with x squared and this one with 2x dx, where we know x is 50, delta x or dx is simply 1. Replace it. By the way, some of you may know you can use this 50 plus 1 squared. This is an algebra. You can use that in your head. 50 squared is 2,500. 2 times 50 times 1 makes it 100, 2,600. And then 1 squared is 1. So it gives you 2,601. You should know this. Okay, this is from algebra, a plus b quantity squared. But in any event, we continue with this. X squared, so 50 squared plus 2 times x, 2 times 50 times dx. And as you can see, this is 100 and 2,500 is 2,600, extremely close to the actual value, which is 26. Oh, let me just erase this. So this is very close. And the reason is very simple, because delta x is extremely small compared to the choice of x. Now, and we are done with that. However, I want to show you a separate method, because if we use linearization, which simply means just find the tangent line, you don't have to memorize this formula, just stick with the elementary algebra, the point slope. So what do you need to find an equation of a line? You need two things. You need a pair. Well, x is 50, plug it in. So 50 comma 2,500. So that's your x comma y. You need a slope, and you use f prime of x, which is 2x. If you replace the x with 50, then the slope is 100. So L of x requires a pair and a slope y minus y1, that means y minus 2,500, is m, that means 100, times x minus x of 1, that means minus 50. And simplification will result in L of x, y, which we are going to call it L of x because it's called linearization, 100x minus 2,500. Since we want 51 squared, if we replace the x with 51, we get exactly what we got here. These two numbers must be identical because the process ultimately gives us the same answer. So they must give us exactly the same answer. How about cube root of 63.5 using the same process? And to do that, again, we need a function. And the function comes with the operation. All you have to do, look at this operation. What are we doing here? Cube root of 63.5. So f of x is cube root of x. The next thing is the closest number to this that we can easily take a cube root of. There is no need for a calculator. And I hope everybody knows the answer is 64 because the cube root of 64 is 4. So we let x be 64, closest number to that. And so notice, because we want to go from 64 to 63.5, we are going down by 0.5. So dx or delta x is negative 0.5. So 63.5 minus 64. However, again, just to make sure everybody understands what's going on, if I was interested in, let's say, cube root of 65, then my dx would be positive one. And that's something you want to be very careful of. And so with that being the case, let's go through the process. And that is f of x is cube root of x, or x to the power of 1/3. We need to differentiate this, which is 1/3 x to the power of negative 2/3. Or we can rewrite this by taking this down and making it x to the power of positive 2/3, or cube root of x to the second power. And if this is the case, as you know, dy is the same thing times dx. The same thing times dx. That's what dy is. And so f of x plus delta x is f of x plus dy. And f of x is cube root of x. dy is dx over 3 times cube root of x quantity squared. And x is 64, dx negative 0.5. So what do we want? We want the cube root of 63.5, which means we can say f of 63.5, which means f of 64 plus negative 0.5. I'm just, again, explaining the whole thing. You don't have to write this if you don't want to. But the point being, replace the x with 64 in both cases, and dx with negative 0.5. So what happens here, this is 4, this is 4. When you square it, becomes 16. When you multiply it by 3, becomes 48. So this piece is negative 0.5 divided by 48. We don't want to have a decimal as a numerator. So if you multiply the top by 2, becomes negative 1. The bottom becomes 96. So 4 minus 1 over 96. As you know, this is 3 and 95 over 96. 3 and 95 over 96 precisely. If you go with the decimal representation, you get 3.989583. And if you go with the calculator, you see that they're extremely close. The first four decimals are the same. So if you do the approximation with, let's say, 3 decimals, they become identical. Here's the second method. The concept of a linearization was discussed. And again, you don't have to memorize that. Just remember the point slope. So if you want to come up with the equation of a tangent line, you need 2 things. You need a pair, and you need the slope. So what is the pair? Replace the x with 64. So 64 is x. Y, or f of x, is 4. 64 comma 4. What is the slope? Well, here's f prime. If you go here, it's easier. Replace it here. You get 4 square root 16 times 3 is 48. 1 over 48 is your slope. And so y minus 4 equals 1 over 48 times x minus 64. And if you simplify it, y, also known as L of x, is 1 over 48 x plus 8/3. Now all you have to do, plug in 63.5 instead of x, and I'm going to leave it for you to verify that if you replace it with 63.5, you get this number, or with a decimal representation, you get that one. Given that f of x is sine x, we want to find dy. And the moment you hear dy, you just differentiate first. F prime of x is dy dx. As you know, it's just cosine x. So what is dy? It's cosine x times dx. Find its linearization at pi over 6. That means in essence, we want the tangent line for this function when x is pi over 6. That's the meaning of it. So linearization means find the tangent line for the function. At what point they give it to you? So we need two things. We need a pair and we need the slope. The slope, just replace this one with pi over 6. And as you may recall, sine of pi over 6 is 1/2, cosine is square root of 3 over 2. We also need a pair. Well, pi over 6 is here. That's your x coordinate. And your y coordinate is sine of pi over 6. As you know, it's 1/2. So the pair is x comma sine x, where x is replaced by pi over 6. So pi over 6, 1/2. So all you have to do, you don't even have to memorize that. Go with the elementary algebra of y minus y1 equals m times x minus x of 1. So y minus 1/2 equals m square root of 3 halves times x minus x of 1 pi over 6. And we want to keep it exact for now. We don't want to replace the pi. Remember, at the end, you may do that, but you want to keep that exact. So you apply the square root of 3 over 2, and then negative 1/2 moves to the other side, becomes positive 1/2. So this is square root of 3 halves x. This is square root of 3 pi. This is over 12 with the negative sign, and then plus 1/2. This is exact. If you don't change this, this is exact. And you can keep it. This is the precise answer. Now, part C. We want to approximate sine of 31 degrees. There are two ways to do that. We can do it with the differential, or we can do it with the linearization. We will discuss this linearization, which is already there, and in no time we're going to get to the answer. I want to start with the linearization and recognize that 31 degrees, that means 30 degrees plus 1 degree. 30 which means pi over 6 plus pi over 180. 1 degree is pi over 180. And the reason we go that, we have to go with radians in calculus. So f of x plus dx is f of x plus dy. And f of x is sine x. dy is cosine x dx. So x is pi over 6 and dx is pi over 180. Very straightforward, everybody. Again, you have to go with radians. This is your x. This is your dx. So sine of pi over 6, cosine of pi over 6, pi over 180. Of course, we know sine of pi over 6 is 1/2. Cosine of pi over 6 is square root of 3 over 2. But we really have to go with the decimal representation, and please don't choose 3.14 for pi. Use a calculator, 3.14159, and it continues indefinitely. So plug in, evaluate, and see what you get. So using a calculator with a bunch of decimals, 0.51512, however many decimals that they ask you. So this is using the differential. If you want to go back to this, sine of 31 degrees is the sine of 31 pi over 180. Okay, 31 pi over 180. So L of x, so you want L of 31 pi over 180. This is 31 degrees, okay, 31 degrees, 31 pi over 180. Because everything is in radians. Everything is in radians. So replace the x with 31 pi over 180. So square root of 3 over 2 times 31 pi over 180 minus square root of 3 pi over 12 plus 1/2. Now, again, you just have to use a calculator on this. Replacing the pi with 3.14 is not a good idea. So use a calculator. And again, you end up with exactly the same answer that you got here, however many decimals they asked you. One side of a right triangle is known to be 20 centimeters long. So we are dealing with the right triangle. And the opposite angle is measured as 30 degrees with a possible error of plus minus 1 degree. So the opposite angle is supposed to be 30, but it can go up or down by 1 degree. So it could be somewhere between 29 and 31 degrees. That's the meaning of that. Use differentials to estimate the error in computing the length of the hypotenuse. What is the percentage error? So first, the drawing and the concept. So here's one side, 20 centimeters long. The opposite angle, theta, is 30 degrees. Since we are interested in the hypotenuse and we have no idea what's going on, we're going to give it an variable x, y, z. You have to define your variable. So x represents the hypotenuse in this example. Use differentials to estimate the error in computing the length of the hypotenuse. So what is given? One leg is 20 centimeters. The opposite angle, theta, is 30 degrees. The theta is plus minus 1 degree. It's specifically given in degrees. And we change it to plus minus pi over 180. And we want the change in the hypotenuse, the error in the hypotenuse. Therefore, we want the x. So we want to relate the x and theta and 20. That's the bottom line, x and theta in essence. And as you recall, sine theta is the opposite over the hypotenuse. So sine theta is 20 over x. And that means sine theta times x is 20. And if you divide both sides by sine theta, you get x. If I divide by sine theta, that means I get cosecant theta on the other side. So x becomes 20 cosecant theta. Now, since I want dx, first I'm going to differentiate and I'm going to get dx d theta because my independent variable is theta. It's important to understand it's dx d theta. Dx d theta if I differentiate. And When I differentiate that, 20 remains. Cosecant is negative cosecant cotangent. So the xd theta is 20 times, now cosecant theta is minus cosecant theta cotangent theta. And so what is dx is the right side times d theta. So the right side is minus 20 cosecant theta cotangent theta, and then times d theta. This is dx. We are going to replace everything accordingly. Now, theta is 30 degrees. So this is 30 degrees. Cosecant is 1 over sine. Sine of 30 degrees or pi over 6 or is 1/2. So cosecant is 2, the reciprocal of that. And cotangent is square root of 3. And then the theta is plus minus 1 degree or pi over 180. Plus minus pi over 180. So again, I want to make sure we understand. This is 30 degrees or pi over 6. Cosecant, we know sine is 1/2. Cosecant is the reciprocal of that is 2. Cotangent is square root of 3. We should know that. Or you may know that tan is square root of 3 over 3, and this is the reciprocal of that. And at this point, it gives us 2 square root of 3 pi over 9 plus minus, and we keep the plus minus because we are simplifying things here. This 20 goes away and this changes to 9. Let me do that. Number 20 can go away and this changes to, and this is precise. Now use a calculator with a bunch of decimals, maybe 1 or 2 decimals, however many decimals they ask you. And we get plus minus 1.21. Now, you want to pay attention that over here, the units were in centimeters. So plus minus 1.21 centimeters. All right. What is the percent error or percentage error? It's the relative error of dx over x. By definition, the relative error is the amount of error, which is dx, over the actual value. Okay. Now, we know the dx, and we can use that. If we want to go with the precise, we can use that. Instead of that one, I would use this one, precise, for a moment. And for x, I'm going to put 20 times 2. And why is it 20 times 2? It has got to do with understanding the sine theta. Theta is 30 degrees. Sine theta is 20 over x, and that is 1/2. Here's the reason. We said theta was 30 degrees. So makes x 2 times 20, because sine theta is 20 over x. Sine theta, we know sine of 30 degrees is 1/2, and x becomes 2 times 20. Again, if you set this equal to 1/2, when theta, let's just write sine of, so sine of 30 is 20 over x plus 1/2, and that's a proof, just to refresh your memory. Now, we can simplify this by getting rid of 20 and 2, right, this part. This goes away. This goes away. So we have plus minus. Although we have a negative class, please understand when you multiply by this one becomes minus plus, which is still plus minus in essence. Okay, minus plus or plus minus, square root of 3 pi over 180. And now you can use a calculator, roughly plus minus 0.03 or plus minus 3%. Again, as far as the number of decimals, you want to pay attention to the way they ask you. The next section, 3.11, is about hyperbolic functions. So I'm going to remind you when we dealt with the unit circle, x squared plus y squared equals 1 squared, cosine squared plus sine squared equals 1. This is basic trigonometry. In hyperbola, in the case of a hyperbola, x squared minus y squared equals 1. So cos squared minus sin squared equals 1, and that's why it's called hyperbolic functions. So unit circle, that the trigonometric functions versus the hyperbolic functions. Now, by definition, cos hyperbolic cosine x equals e to the power of x plus e to the power of minus x over 2. Sinh hyperbolic sine by definition is e to the power of x minus e to the power of minus x over 2. This is by definition. And then a few stuff follow. We had trigonometric identities, not now hyperbolic functions have similar identities. We look at some of the proofs. We have done it already, but in the lectures. For example, cos squared minus sin squared equals 1, whereas in this case, cosine squared plus sine squared was 1. Hyperbolic cotangent squared minus 1 is hyperbolic cosecant squared x, so on and so forth. We have those. We're going to look at some of them to add this. These are by definition. Hyperbolic tangent, if you remember, tangent was sine over cosine, so it's sinh over cos. Cotangent was cosine over sine. Hyperbolic cotangent is cos over sinh, and hyperbolic cosecant is the reciprocal of hyperbolic sinh. If you recall, cosecant was 1 over sine, and hyperbolic secant is the reciprocal of hyperbolic cosine. If you recall, secant was 1 over cosine. So this one is by definition. Okay. So other identities, for example, sinh minus x is minus sinh x. You may remember that sine of minus x is minus sine x, and cosine of minus x is cosine x. The same thing happens here. And then sine of x plus y, cosine of x plus y, we have things like that here. And then we have the derivative function. The derivative of sinh x is cos x. If you remember, the derivative of cosine was negative sine, but in this case, that's not the case. The derivative of cos is sinh, so on and so forth. We also have inverse hyperbolic functions. We're going to lightly go over that, and we remember the trigonometric functions, the inverse trigonometric functions as well. For example, the derivative of sine inverse x is 1 over square root of 1 minus x squared. And so this is just to refresh everyone's memory as far as some of the formulas you may have seen in your lectures. So hopefully this is pretty straightforward, and that takes care of the business for the sine inverse, cosine inverse, and so on and so forth. All right, cos squared minus sinh squared equals 1. We want to prove that, and we remember by definition, cos is e to the power of x plus e to the power of minus x over 2, and sinh is the same thing with the negative in between. So we are going to replace each one with its definition. So on the left side, remember when we proved trigonometric identities, we started with the more involved, more difficult side. In this case, we're going to go with the left side. So all we have to do square each one. So obviously, when you square this, the denominator in both cases becomes 4. And the numerator, you square this one. Okay, a plus b squared is a squared. Let me just write that everybody knows. A plus b squared is a squared plus 2ab plus b squared. If you have a negative sign here, we're going to have a negative sign. Therefore, so e to the power of x, the second power is e to the power of 2x plus 2 e to the power of x, e to the power of minus x plus e to the power of minus 2x. This one, the same thing with the negative in front. So this is what happens, and I want to write this one. I want to make sure we understand what happens with this one, because this one, and by the way, this is 4, this is 2 e to the power of x times e to the power of minus x, and that becomes 2 e to the power of 0, that becomes 2. That's how we arrive at 2. Now, if you add those in the following manner, so let me just write this with one fraction bar. So we have e to the power of 2x plus 2 plus e to the power of minus 2x. Now we have a negative sign here. We are going to apply. Let me use a different color. Minus e to the power of 2x. Now that minus 2 becomes plus 2, and then minus e to the power of minus 2x. As you can see, everything cancels out except 2 and 2, they add up to 4. 4 over 4 equals 1. So that's a proof. We want to prove that 1 minus hyperbolic tangent squared is hyperbolic secant squared. So we are going to start with one of those identities, which was cosh squared minus sinh squared equals 1. And in order to make it look like this, in order to get 1, let's divide everything by cosh squared. We're going to divide everything because we want to get 1, right? We're going to divide by cosh squared. So as you can see, this is 1. Sinh over cosh is hyperbolic tangent. So minus hyperbolic tangent squared. 1 over cosh is a hyperbolic secant. So hyperbolic secant squared. So believe it or not, that's the proof. Very straightforward, everybody. We want to differentiate sinh 10x squared. And so the derivative of sinh x is cosh x. So first and foremost, the way I want you to read it again, just the way we did it with trigonometric functions, just read sinh. Just sinh. The answer is cosh. And you have to write the argument, so cosh of 10x squared. By the chain rule, we need the derivative of 10x squared times 20x. This is by the chain rule, everybody. And we put that in front, we are done. We want to take the derivative of cosh, so it doesn't matter what this, just read cosh and stop. The derivative of cosh is sinh. It's not negative, so you want to be careful. It's not minus, so it's sinh. So you write sinh of the same argument, sinh squared of x. And then you want to, by the chain rule, you want to come with the derivative of square root of x. You may know by now it's 1 over square root of x, but if you don't know, this is x to the power of 1/2. Its derivative is 1/2 x to the power of negative 1/2, which is 1 over 2 square root of x. And you just rewrite this expression, everybody, and you're done. F of x is hyperbolic tangent of 1 plus e to the power of x. So you want to differentiate this. You want to find f prime. Just read that. Hyperbolic tangent is hyperbolic secant squared. So hyperbolic secant squared of the same argument. So the same thing. So you have to write the same thing, everybody. You have to put this in here. Now, by the chain rule, we need the derivative of this argument. Well, 1 is a number and the derivative is 0. This is exponential. The derivative of any exponential is itself. Again, by the chain rule, you need the derivative of 2x, which is 2. We are done. We are going to rewrite this by putting this in front, this in front. 2 e to the power of 2x hyperbolic secant squared of 1 plus e to the power of 2x. All right, lightly, we're going to go over the inverse of hyperbolic functions. So, for example, y is sinh inverse of x squared. As you may recall, the sine inverse, the derivative was 1 over square root of 1 minus x squared. But for sinh inverse is 1 over square root of x squared plus 1. It's similar. For cosine inverse was negative 1 over square root of 1 minus x squared. So this one changes here, x squared minus 1, 4. Tangent was 1 over 1 plus x squared. For the hyperbolic tangent inverse is 1 over 1 minus x squared. So it's pretty similar. And so we are going to go with this formula, which means really whatever this one is, if you look at this formula, it says whatever this one is, square that. And if you call this g of x, then this is g of x that gets squared, and then you need g prime of x. Okay, so in fact, I'm going to write that because I want you to see this. If I have sinh inverse of, let's say, g of x, then I need 1 over the square root of, I'm going to write g squared instead of g of x because of the space, g squared plus 1, and then this is the chain rule class times g prime. So with that being this case, 1 over square root of, I'm going to square this, becomes x to the power of 4 plus 1, and then g prime, the derivative of that is times 2x. This is by the chain rule, everybody. And just rewrite it. What if it was tan x? The same thing. I'm going to write the same thing. 1 over the square root of x squared plus 1 becomes tan squared plus 1. And then I need g prime, the derivative of tan x, which is secant squared. Now, some of you may recall that tan squared plus 1 is secant squared. And because it's in the square root, it comes out as absolute value of secant x. If you divide secant squared by absolute value of secant x, you still have absolute value, okay? Because the numerator is positive and the denominator is also positive, you have to put it in an absolute value. We want to differentiate this, and I'm going to put a raised dot, meaning I'm looking at a product rule of f times g and a shorthand notation f prime g plus g prime f. So e to the power of x is itself times the second piece, whatever it is cosh x. Now plus g prime plus cosh x, the derivative is sinh x, times the first piece e to the power of x. And since e to the power of x is in common, I can factor e to the power of x out. Now, you really shouldn't leave it like that. I hope you recognize if you add these two, this one and this one cancel each other, you get 2e to the power of x over 2. I hope you see the sum of these two is e to the power of x. And look at it. Add these two, the sum is e to the power of x. So e to the power of x times e to the power of x makes it e to the power of x plus x, or e to the power of 2x. And that's it.